Okay, which one must we do, guys? Which one? 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 Maths paper 1 revision. Grade 12. Which one? Which one? Which one? 1.1, 1.1, 1.1.2, 1.1.3, 1.4, 1.1.5, 1.2, 1.3. Yeah? Which one? Which one must be done, guys? We leave this page when we are saying everything we can do here. Everything. Okay? Everything. Standard. We can do it. Which one? Which one? Hmm? Hmm? Okay, everything here we can do is no problem. Which one? Which one? Last one. Oh, okay. Let's do the last one then. We're saying the last one. Let's do it. Let's do it. Let's do it. Let's do it. Okay, let's check it out. The last one. Check it out now. To God be the glory. Check it out now. To God. Let's just zoom into the 1.3 now. Given that f of x, right? It's very important to see. Given that f of x is equal to x squared plus 3x, ne? And Anna Selman Nanyin, I hate math in my life. I'm very sorry about that, my dear. Mwah. All right, that's it. There's me blowing a kiss to you. Mwah. Anna Selman Nanyin. Then f of x is equal to x squared plus 3x. That is, a function. Okay, and what type of function is it? Because it's x squared plus 3x, it's a parabola. Then we have 2x minus square brackets 2 to the t to the power tx, sorry, all raised to the power half is equal to 0. Then they are saying for which values of k will what? This equation. See the setup of this equation? They're saying f of negative x. So we are going to have to go to this function there, and we are going to have to substitute f of negative x. So in the place of x here, we substitute negative x. So we say negative x, the whole thing squared. Remember, there's an x squared. So we say f of, in the place of x, we put negative x, the whole thing squared. Does that make sense? Does that make sense? I hope you understand. Then we say plus 3. In the place of x again, we put another negative x. Does that make sense? Then that f of negative x. So if we apply the square to the negative sign, we get a positive sign. And then if we apply the square to the x, we get x squared. Positive times a negative is negative. Then 3 times x is 3x. So that's f of negative x. So what we are going to replace f of negative x with is this. We got f of negative x. Now, it's time to go to t to the power 2k, right? t 2k, t2k. So let's rewrite this. Let's come here. Come and rewrite tx, all of it to the power half. Take, this is negative of that, take the 2x over. That gives you 2x, negative 2x. Does that make sense? because we take the 2x, we transpose it, it becomes negative 2x. That tx negative into the brackets tx to the tx, all raised to the power half. We are now going to divide both sides by negative. We get tx to the power half. A negative divided by negative is a positive, so that gives us 2x. And if we want to get rid of the square, we take the reciprocal of square of half, tx to the power half, we square it. So what we do on the left, we do on the right. So that gives us t of x. That cancels with that, so we're left with t of x is equal to, apply the square to the 2, we get 4. Apply the square to the x squared, we get 4x squared. So this is t of x. Okay, yeah, so I just took this equation here and I rewrote it so that t of x becomes the subject of the equation. So I isolated negative t of x, the whole thing to the power half, took the 2x over, that becomes negative 2x. So confused. Anna Salma Nanyen, I think your attitude as well is going to make you even that much more confused. The thing is, your opening statement said, Salma, let me remind you, I hate maths in my life. Seems like we've got a blockage. All right, Selma, I'm going to take it one step at a time. Please observe. Ne? Remember, I said there was f of x is equal to x squared plus 3x. Selma, do you want to come up and talk to me? All right. F of x is equal to x squared plus 3x. All right. Now, the question says, for which values of k will the equation, yeah, Anna. Hello, Anna Mana.
Can you hear me?
I can hear you very well. How are you doing, Anna Mana?
I'm good, and how are you, Sam?
I am doing very well, thank you.
This topic that you are teaching me, the method that you are teaching me is different, but all I want to say is really little bit confused.
Oh, okay. Where are you from, Anna?
I'm a Namibian.
Oh, okay. Nice. Okay. So I think I hear you, Anna. I was just, I guess, yeah, if it's okay, I'm glad that maybe you have a different way of doing it, and that's okay, as long as at the end of the day we're able to get to the same place, same answer.
Okay.
Yeah. So, like I was saying, I looked at what was given. So we are given two functions. This one, which is f of x is equal to x squared plus 3x. And then the second function, which is 2x minus, then we have the square bracket, but inside there's t of x, all raised to the power half, and it's equal to 0. Okay?
Okay.
So the question says, for which values of k will the equation, meaning this one, have equal roots? I'm sure you can see that in this equation, we have two terms, f of negative x plus, then we have t into 2k over 4. So I can see this first term having... Wanted to say something?
Yeah, I wanted to say something. That it means the first one we are going to substitute or something.
Yes, very true.
Okay.
For the first one, we are going to look at this given function f of x, and then we are going to take the f of negative x, substitute the negative x in the place of x for the function, which is what I did here. So I decided to just take each separate term, deal with it separately, and then eventually I'm going to put them together, equate to 0, and then I'm going to answer the question. Okay. So f of negative x there, I take the negative x, substitute here in the place of x. Negative x there and negative x there in brackets. So that's why I have f of negative x is equal to negative x in the place of x, inside brackets, squared, because there's a squared there, plus 3, that 3, plus 3. Then in the place of x, I put another negative x. Then you apply the square to the bracket. First to the sign. An even exponent applied to a negative sign leads to a positive sign. Then an even exponent applied to x leads to x squared. So my first term is positive x squared. Then plus 3 times negative 3. A positive times a negative is a negative. 3 times x is 3x. So I have f of negative x being x squared minus 3x. So I hope we understand this one for f of negative x.
Yes.
That's fine, right? Yeah.
Yes.
Then I can see here for the second term, there's t of 2k. So what I'm going to first do, I'm going to come to this function here, because I can see it has t of x in it. I am going to make t of x the subject of this equation or this function. So I take the equation, all of it. I take 2x and I transpose it to the right hand side, which is what I did here. So I'm left with negative square bracket t of x square bracket raised to the power half equal to what? Negative 2x. Does that make sense?
Yes, yes.
Then, because this is negative t of x raised to the power half, I'm going to divide the whole entire term by negative 1 to get rid of this negative. Okay? Then what I do on the left, I also do on the right. Divide by negative 1. That leaves me with t of x still raised to the power half. Okay? And then on this other side, I'm left with positive 2x. But because now I want to get rid of this exponent half, I multiply the exponent with its reciprocal exponent, which is 2 over 1. So that cancels the 2 and the 2, the 1 and the 1, and I'm left with t of x on the left. But if I am going to multiply the exponent half by 2, I'm going to do the same thing to 2x on the right-hand side. This exponent 2 applied to the 2 is 4. This exponent 2 applied to the x gives me x squared. So now I have t of x, which is equal to 4x squared. Now I'm ready to apply t of 2k for this function. So I was going to do that next. Apply t of 2k. Substitute. So if I say t of 2k, it's going to be equal to 4 into 2k raised to the power 2. So I substitute in the place of x 2k. That gives me 4, the 4, into 2k squared. Are we making sense together,
Yeah.
Anna? And then I am going to BODMAS. BODMAS says I must first brackets, then O exponents and roots, orders. So if I apply the exponent first to the 2, the 4 outside, I apply the exponent to the 2 squared is 4. Apply the exponent to the k, I get k squared. Final answer, 4 times 4 is 16, 16k squared. That's 2 of 2k. That's what 2 of 2k is equal to. It's equal to 16k squared. So, Anna, I think we are ready now to bring... Yes.
Understandable, but I understand now. I go to, but I require more practice about it.
Which is okay.
Yeah, simultaneous is not easy. So require practice.
Yeah, for sure. Well, I hope you practice and you get better at it, Anna. I'm
Yeah.
sure the more you practice, you will be 100%. You'll be good.
Yes, true.
Yeah. Well, thank you for joining, coming through. I really appreciate.
Okay.
Yeah, I'm going to just finish it off, but thank you for joining.
Okay.
Thank you, Anna. Okay. So guys, now that I have the expression of f of x, which is x squared minus 3x, that means I'm going to take x squared minus 3x and come and substitute it in the place of f of negative x. And then, since I have the expression of t of 2k, I'm going to, which is 16k squared, I'm going to substitute that 16k squared in the place of t of 2k. Does that make sense? And then I'm going to write the actual equation equated to 0. So let's do that. F of negative x, there it is. F of negative x is x squared minus 3x. That's f of negative x. Plus, we write the plus, then the t of 2k is 16k squared in the numerator. 16k squared over what? Over 4 equal to 0. Then let us simplify this. We get x squared minus 3x. What's 16 divided by 4? That gives us positive 4. For what? 4k squared, which is equal to 0. So this is the equation which they are asking now. For which values of k will the equation, which equation? Here it is. We've now gotten the actual equation. For which values of k will this equation have equal roots? So this is nature of roots. This is actually a long root, nature of root question, which says for which values of k will this equation have equal roots. So what do we do when we have an equation now that is in standard form? Remember, this is our x squared term, this is our x term, and this is our constant term in terms of k. So when we are here, what is the next step? In grade 11, we did for which values of k will the equation have equal roots. So obviously this is a prescribed condition. What does equal roots mean? Okay, so we use what we call the discriminant or delta to be able to determine for which values of k will this given equation have equal roots. Okay, so you see this whole entire process that we are performed here, getting f of negative x, getting the expression which is x squared minus 3x, getting t of x to be first sorted, and then getting t of 2k so that we can get the expression of t of 2k. then taking this and that, substituting it here into this equation, getting this simplified equation, and now ready to actually do what? Find the values of k, which this equation will give us what? Equal roots. So when we are here, guys, it's a matter now of doing this. Okay, I'm just going to go here at the top, guys, and I'm sorry for that. We are going to come here, x squared minus 3x plus 4k squared, which is equal to 0. First step, you need to identify a, b, and c. A is 1. Remember, a is the coefficient of x squared. B is negative 3. B is the coefficient of x, and then c is 4k squared. Then guys, when we have identified a, b, and c, what do? We use the condition. Whereas when they say for which values of k will the equation have equal roots, that means delta is equal to 0, guys. That's what it means. Delta is equal to 0. So then we can say b squared minus 4ac is equal to 0. Right? Because delta means b squared minus 4ac. That's the discriminant. We equate it to 0 because they want the values of k for which this equation will have equal roots. We have found the equation. There it is. It's x squared minus 3x plus 4k, which is equal to 0. Identify a, b, and c. Since they said for which values of k will the equation have equal roots, we say delta equal to 0. Delta is b squared minus 4ac is equal to 0. Then please allow me to erase everything that I've done here, because we saw how I got the equation, which is the most important thing that we were able to do through all that I wrote here. Now b squared minus 4ac is equal to 0 means now we can substitute in the place of b. Okay, b is negative 3. So say negative 3 squared minus 4. In the place of a, we substitute 1. C, in the place of c, we substitute 4k squared. We say equal to 0. Then from there, 9 minus times a positive, that gives us a negative. 4 times 1 times 4 is 16. And then k squared. Then what you can see here is the difference of two perfect squares. 9 is a perfect square, minus is the difference. 16 is a perfect square, k is a perfect square. So we can factorize this. Square root of 9, that's 3. Different signs, positive and negative. Square root of 16, that's 4. Square root of k squared is k. So we have 4k, 4k. So 3 plus 4k is equal to 0, or 3 minus 4k is equal to 0. Then from there, guys, we get the values of k. We isolate 4k here. We transpose 3, it's negative 3, divide by 4 both sides. We get k is equal to, the first value of k is negative 3 over 4. Or we isolate negative 4k, we transpose 3, that becomes negative 3. We divide both sides by negative 4. That gives us k is equal to positive 3 over 4. Those are the values of k, guys, that we need. Okay, so we've solved for which values of k will the equation, which equation? That equation that we got, have equal roots. It's when k is equal to negative 3 over 4, or when k is equal to 3 over 4. Understood? 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 Any questions? We understanding well? So guys, this might look like an intimidating question, but it's very nice. This question, very nice. Okay, very nice. Explain the 5 mark is for. Well, honestly speaking, Anna Salma, all right, the 5 marks, okay, I think is probably for all that work that you did, right? Maybe, yeah, because remember, we had to first take the f of x and substitute f of negative x. So I'm sure there's probably just a mark attached to that substitution together with this substitution of t of 2k, because remember you had to first make t of x the subject and then substitute t of 2k in the place of x in that function as well. Then you were able to get an expression which ultimately, when you got f of negative x, you got x squared minus 3x, which is what you wrote first, plus then t of 2k. When you substituted t of 2k in this equation, you got 16k squared for the numerator, but then you divide it by 4. Hence, 16 divided by 4 gives you 4, so you have 4k squared. This is the equation in standard form that we are going to be using so that we can be able to answer for which values of k will the equation f of negative x plus t into of 2k over 4 equal to 0 have what? Equal roots. So it's important we understand the condition of the discriminant that we are going to have the discriminant in order to solve for the values of k. So since they will have equal roots, that's why we say delta is equal to 0, meaning the discriminant b squared minus 4ac, we ought to equate that to 0. And we know that b is the coefficient of x. We know that a is the coefficient of x squared, and we know that c is the constant term that is in terms of another variable that is not x. Okay, so since it's 4k squared and it's positive, we know we take the entire thing for c, substitute into the equation, solve, for k, and get the k values, and there they are. K is equal to negative 3 over 4, or k is equal to positive 3 over 4. So if ever there was a question that looks intimidating and difficult but is very easy, it is question 1.3. It's an incorporation of all the important, so functions are in there because these are f of x and t of x. Literal equations making, f of x and t of x the subject, that's all in there. So it's your algebra, basically, your application of algebra. Substitution, okay, that's in there as well. Simplification is in there until you can get this equation. And once you are here, you are in familiar ground, because from here, you are literally answering for which values of k will the equation have equal roots. So that's nature of roots. And in order to be able to determine for which values of k, you need to interpret the condition of delta based on the statement. Since it says equal roots, that's why you say delta is equal to 0. If they had said real and unequal, we would have said delta is greater than 0 alone and then solved the inequality. If they had said that has non-real roots, we would have said delta is less than 0 and then solved the inequality where delta is less than 0. So you must always check what the condition of the discriminant is, so that you can then be able to solve for k accordingly. All right. So guys, yeah, equal roots, it just so happens that one, that's why we said delta is equal to 0. And it said for have non-real roots, we would have said delta is less than 0 and solved an inequality. If it would have said real and unequal, then we would have said delta is greater than 0 alone and then solved an inequality. If it would have said have real roots, then we would have said delta is greater than or equal to 0 and then solved an inequality. So we must be able to ascertain the condition of our discriminant so that we can set up an appropriate either equation or inequality and then solve it. Okay. Any other questions, guys, that we have from this page? Any question that you guys want to be explained on this page? Any question that is like catches your attention, you want it to be explained? We've got 1.1.1, 1.1.1, 1.1.3, 1.1.4. You're welcome, Anna Salma. Practice makes permanent. Practice makes perfect, but it also makes the maths permanent. So happy practicing, and thank you so much for joining the segment that I was explaining this question. Anyone who feels like they want explanation for any other question here? Or should I move on to something else? Otherwise, we are sorted with everything else. Everything else is like easy capeasy, easy lemon squeezy. Okay, I think it's easy lemon squeezy. That's why no one is saying anything. I think we are good. The one. Yeah, if you have that name, you must know that you are brilliant. The one. Yeah.
Hello.
The one. What's up, the one?
Can I ask 1.3?
Yeah, 1.3 is the one that I just explained. What about it, my man?
What does it mean?
Okay. So do you know nature of roots? You remember the topic nature of roots?
Yes.
Yeah. So this question is a compilation of many aspects in maths. So let's first look at, I'm gonna just go over it again one more time. So if we look at the givens,
Yes.
are you familiar with the first given? What is this? What do we call this?
A quadratic equation.
Yeah, it's a quadratic function, right?
Function, yes.
Yeah, parabola. Then if you go to the bullet point, the second bullet point,
Yes.
okay, what is this?
It's a function.
Yeah, it's the function, right? So both of these are actually functions, right? And I think when we simplify or when we make t of x,
Yes,
the subject, we quickly realize that if we transpose, so for instance, if we transpose 2x on the other side,
yes,
and then we apply the exponential reciprocal because it's raised, t of x is raised to the power half,
yes,
then we are actually going to multiply that exponent by 2, right? So that we can get rid of the half.
yes.
What we do on the left, we do on the right. Ne?
Yes.
So which means you are going to get 4x squared. Do you get that? So if we take 2x over, that becomes negative 2x.
Yes, it's going to be negative 2x.
Yes, then you divide both sides by a negative because both terms are going to have a negative, ne? Both terms.
Yes.
Then after dividing by a negative, you are going to apply the exponential reciprocal. You multiply the half by 2 on the left to get rid of the exponent half. Are you with me?
I put 2 to cancel.
Yeah, to cancel.
Yes, I'm with
you. You have tx to the power half, right? But then you multiply by 2, the exponent 2, to get rid of this half. But what you do on the left, you must do where? On the right.
On the right.
It will also be multiplied by squared.
That negative is becoming positive.
Remember that negative?
I see.
Remember that negative would have been there, both sides. Then we divide both sides first. Before anything, we divide both sides by a negative to get rid of the negative on both sides.
I see.
So that leaves us with positives on both sides.
Okay.
Okay. Yeah.
I saw the first part. Yes.
Yeah. Then we apply the exponent. We
Yes, I
square
understand
both,
the
right?
first part.
Yeah. Then we get eventually the t of x, which is equal to 4x squared. So that's how I got here.
Yes. Now I
Yeah.
understand. Then
So hence I'm saying to you that both of these, f of x and t of x, are both quadratic functions. Both.
oh, they are both quadratic functions.
Yeah, they are both quadratic.
Yes.
But if you leave now, so the givens, we have simplified the givens so that it speaks a simplistic sense to us. There's simplicity now in the givens.
Yes.
Now we come to the question. It says, for which values of k will
Yes.
the equation, and look at what they are saying, f of negative x.
Yes.
Yeah? So let's just pause there. F of negative x, that means I can take f of negative x, substitute here, and get the actual expression of f of negative x.
Okay.
So f of negative x, it means I can go and substitute negative x in the place of x here in the function, and I will
Okay.
get the expression that represents f of negative x.
Yes.
Yeah.
Yes.
When you do it, I mean, you can do it on the side, you will get x squared minus 3x.
Yes.
So in the place of f of negative x, you'll have x squared minus 3x when you substitute this here.
Yes.
Then let's move on. So we'll be done with the first term. Then there's a plus sign to indicate that t of 2k over 4. This means we need to substitute in the place of x here, what? 2k.
We put 2k, yes.
Yeah. Then that means we are going to get a unique expression in terms of k. What that expression is 16k squared.
16k squared.
Yeah, you
yes.
can check it yourself. You can check it if it's like that. 2k, if you square it, you get 4k squared. And then 4 times this 4k squared times this 4 gives you 16k squared.
Yes, I see.
But then all of that you are going to divide by who?
By 4.
Yeah, which is there. There it is, by 4.
Oh.
And then that's equal to what? To 0. You?
Yes.
Yeah.
Yes.
You simplify this now. X squared minus 3x plus 16 divided by 4 is?
It's 4k squared.
Exactly. So this is your equation. Now I think you are at a place where you should know what to do. Because what are they asking you? For which values of k will this equation have equal roots?
I say the discriminant must equal to 0.
You are done, my guy. And I'm sure you will be able to chow the marks after that.
Thank you. I see.
It's chow time. Yeah. Okay. So basically then what this is saying to anyone, and I mean, sometimes I know learners will say that 1.3, question 1,
Yes.
1.3. 1.3 is vary from question paper to question paper. Examiners have made 1.3 a question that and they make it level 4, most of the time and some of the time. But then the level 4 question is actually, if you can take the time to analyze, right, you should be able to make some connection and get around it.
Yes.
But your algebra, your knowledge of maths for all the content in paper 1 and paper 2 needs to be solid so that your application can be spot on, right? And then apply common sense. Like there's literally like a tinge of common sense that you need to have when doing questions of this nature. Otherwise, it's doable, whatever the question is like, right?
Yes.
Yeah, so someone like the one, the name itself speaks volumes. The one needs to make sure that he spends, so, I mean, typically most question 1 is 24 marks. The one needs to make sure that he slices all these questions, because these are pretty routine and procedural questions. You should take minimal time and just do these and get accurate, like you should get all these marks here.
Yes.
When you get to 1.3, deservedly, it should get some of your time, but it shouldn't be time spent too long here. I mean, of course, you spend less time in these ones, you do them, they are procedural questions, you get the full marks, and then it gives you, because you go through all these questions nicely, you should have a lot of time to then spend here so that you can be able to answer it accordingly.
Thank you. Yes. Yes.
Yeah. So I believe in you, the one. You are the one, Moss.
Yeah, I'm the one.
Yeah, the one. You are the one. The one cannot be not that one, you know?
Yes.
Yeah.
Yes.
Yeah.
Yeah.
Yeah. So that's it,
This
my
question.
guy. I think that was the only one, Moss, you had you wanted to ask about.
Yes, it was the only one that I wanted.
Sure, my guy. I can show my guy.
Yes.
Okay. Yeah, guys. So we are good, ne? I think I re-explained it now. Second time, we are good. There are no further questions, Your Honor. My brother, yeah, my brother, you well? yeah, my brother. Aye. Then if there isn't, guys, let's venture and check some other from other provinces. That was Eastern Cape, right? That was Eastern Cape, one year, once upon a time. All right. So I'm expecting you guys to be able to answer these no problems. Like, pretty fresh, routine, sweet questions. We just need to make sure. But guys, you see the danger sometimes in simplistic, basic questions where like it's like pretty routine and you guys know what needs to be done. Some of you take things for granted, and you lack that finishing and the accuracy that you need to have. So please ensure, please don't take things for granted. You need to also make sure that each and every single one of these questions you can answer correctly. So for instance, question 1, pretty straightforward, standard, of course, like product of factors equated to 0, so it's straightforward. You apply the zero factor law, you write your roots, your solutions, straightforward. This one, they say correct to 2 decimal places. Get your equation in standard form first, then the minute it says correct to 2 decimal places, that's like quadratic formula in your face. You use quadratic formula. You make sure you round off, guys. Please don't mess up rounding off. Round off to 2 decimal places. It must be 2 decimal places. Please ensure that the rules of rounding off are clear. Okay. Raja Casablanca, don't tell us about school. It's weekend. Don't join my live, Kalokuchin. I mean, it's as simple as that. Don't come and, I mean, if by the fact that you actually stayed and you typed, don't tell us about school, it's weekend, it means when you are feeling nambeza, you are having a guilty conscience, and now you are coming here. When if you know you don't want me to tell you about school, you can just switch on to the next live. What's wrong with you, this guy? Then 1.1.3 inequality, please guys. Standard form. This inequality is in standard form. You factorize after that. After factorizing, you write down the critical values. After writing down the critical values, your graphical representation of the critical values in a sketch, please guys. And then after that, you finishing touch, write the answer of the inequality. Please guys, please. Less than or equal to 0 means below and on the x-axis. Below and on. And if it's below, guys, it means the answer is situated between the critical values. BB. Below and between. Below and between the critical values. If it's greater than, we know it's above and away. Above and away from the critical values. Are we together? Simultaneous equations. Oh, guys, glorious marks, those ones. Sorry, said equations first. When you are sad and you are alone, you must go and check. Because people like checking in corners and so forth. So when you are sad and you are alone, this is a sad equation. When you are sad and alone, you set equations, you must make sure that you isolate the set, you square both sides. After squaring both sides, you basically move it along until you are able to get your standard form. Yabo? What do you mean by critical values again? Aibo key. Hey, yabona ke key. Yabona you. Key girl. All right, let me just recap for you what I mean by critical values. Critical values means intercepts or roots. Okay. Critical values are intercepts. No problem, Key. No problem. I'm happy to re-explain. Critical values mean x-intercepts or your roots. Okay. X-intercepts or your roots. Those are critical values. X-intercepts or roots. So let me just show you what I mean by that. Just quickly remove this so I can. It's Hakuna Matata. It's no problem free philosophy. Kiki, you know that is key that you are asking what you are saying, what you are asking. It's key. Okay, it's very, very key. It's key. Making sure is key. Everything is key. Okay, this guy. Okay, this girl. This one. X squared plus 4x minus 12 is less than or equal to 0. So that's standard form, because your equation must be in standard form. Ax squared plus bx less than or equal to 0. Next, factorize. Next step. That means me and you, the open, the brackets. Key better to practice every. I'm panicking because October I'm writing my final exam for mathematics. When you be live and do question 2 and 3, I want to nail this exam so bad. Busi, you better nail it. Me, I want you to nail it so that you can nail us all, you know. Just like they nailed someone on the tree, you must nail the exam. It's very important. He was nailed on the tree so that you could be able to succeed. So x squared plus, no, this is grade 12. X squared plus 4x minus 12 factors. Okay, obviously that means when there's a negative constant, different signs, the highest factor is going to be positive. So we have positive x negative. Factors of 21, we have 7 and 3. Because 7 minus 3 is 4. 7 times negative 3 is negative 21. So it works out. So this is our factors. Critical values, we say CV. In this bracket, what would make there to be 0? It's when x is equal to negative 7. That's your first critical value. The second critical value, what would make this bracket be 0? When x is equal to 3. That's what we mean by critical values. It's like your solutions, your roots. But critical values are not our solution, our final solution. They are our way station to the answer. Then I said graphical representation. Okay. Small critical value, big critical value. That's what I mean. Then less than 0 means below the x-axis. That's what less than 0 means. It's where y is negative. Y is negative on a Cartesian plane below the x-axis. Then equal to 0 means on the x-axis. So you are looking for two things here. Where is the values of x showing you where the function is below the x-axis? And equal means where is the values of x showing me where the function is on the x-axis. So there's two things. On the x-axis, exactly at negative 7 and 3. Then below the x-axis, between the critical values. So then when we write our answer, we are going to say x between greater than or equal to negative 7, less than or equal to 3. Okay, does that make sense, guys? Yeah. So that is it. Critical, yes, sweet peas. But you must make sure that you write this guy. You must write CV. Because no one needs to think that when you write this, if you write this, without the CV. It's almost as if you don't write the CV there, that means you are not acknowledging that those are critical values. Critical values are sort of like your landmarks where you can judge where the answer is going to be. It's like landmarks, important critical landmarks. You know, when you go to a place that is very new, okay, you go to a place that's very new and you don't know that place, and then people tell you about the shop, You're My Friend, you know, that's situated in a particular corner, or the big streetlight pole that is taller than all the others, you know, you must turn there. It's like those are important landmarks in that area or that region. You know, they help you to be able to find the place that you are looking for. So on your way there, those are your landmarks. So it's like -7 and 3 are your landmarks, but they basically just define whereabout, okay, you can then be able to get your answer. So yeah, less than 0 means below the x-axis. Equal to 0 means on the x-axis. So you then write the answer, guys. Okay, that's why I said to you that if it says less than 0, it's below the x-axis. To me, I take that to be BB, meaning below and between. Below the x-axis, between the critical values, there. And then your inequality signs are all sort of like opening their Pac-Man mouth to the right. Pac-Man, eh? Remember Pac-Man? Pac-Man. much. Pac-Man all the way. Yeah. Please. If it was, let's say if the inequality sign was greater than or equal to 0, then that would mean above the x-axis, but away. Okay. The greater than part means above the x-axis. So the answer would be above and away from the critical values. So if, let's say, for instance, this was the case here, it was greater than or equal to 0, I would have said x is less than or equal to -7, or x is greater than or equal to 3, because the answer would lie literally, when we mean away, it's like this side and that side. Okay, this side x is less than -7, this side x is greater than 3. Okay, but then if there's the equal sign as well, we'd include the equal sign. If there's no equal sign, we wouldn't include it. Okay, hope that makes sense, guys. BB, below and between. AA, above and away, above and away, above and away. AA, above and away, but BB, below and between. It's like BB, below and between. Okay, so anyways, guys, I think the point has been made, right? Point's been made very nicely. No cry, right? I think I'm done. Key, are you kid? I hope you are kid. I hope key has been keyed, right? Yeah, so I'm just checking out these guys. If people have any particular things that they want clarity and clarification about, please let me know. And then Mr. tell them how to see if it lies in between or outside. What do you mean tell them how it lies in between or outside? I just did. Okay, you're just okay. So sorry, let's just write that we said x plus 7, x minus 3, let's say less than 0, and then let's write another one, x plus 7, x minus 3, let's say greater than 0. So as I was saying to you guys, less than 0 means below the x-axis, because that's where y is negative. Less than 0 means negative, but below the x-axis, that's where y is negative. Greater than 0 means above. Because now this guy, someone is insisting I need to show. Network, mister. Hi, my network is fine. It's your network, my guy. Sweet peas, it's your network. Don't put me in your network issues, me. Unless people can tell me that my network is conquering, let me hear them. But my network, I think it's fine. Critical values, x is equal to -7 or x is equal to 3. That much is true for both. You put CV, please. Then graphical representation, -7 and 3. Since it's less than 0, where I'm shading is between. That's between the critical values. So then I would say, write x in between. Bachman opens his mouth with his mouth to the right. -7 and 3. Okay, but if it's above greater than 0 means above the x-axis, guys. So our graphical representation, okay, above the x-axis is sort of like situated on this side. You see what we mean by above. So we have -7 here, we have the 3 there. So on this side of -7, we say x is less than, these are values on this side, the x values on this side of -7 are values that are less than -7. The values on this side of 3 are values that are greater than 3. So that's why we say x less than -7 on this side. Whereas here we say x greater than 3. Okay. Guys, there are situations sometimes where this inequality thing, you have x minus 3 into x minus 3, and maybe they say less than 0. Hey, one critical value, hey bana, x is equal to 3. Hey bana. Then what do you do when there's one critical value, but it's sort of like giving quadratic vibes, right? Then here, guys, here is a graphical representation. Let me just show you. There's 1. So let us be honest then that this graph does not cut at 2 places. It turns. There, you see? Now, we are asking less than 0, meaning we want to check where is the function below the x-axis. My question is this function anywhere below the x-axis? Do we have this function represented anywhere below the x-axis? Just answer that question for me. When there's one critical value, guys, it means that there's one x-intercept, which means the function touches just that place of the x-intercept and turns. It does not cut in 2 places like when we have 2 critical values. When we have one critical value, this function touches one place. So my question now is the function situated anywhere below the x-axis? Remember, this line, this horizontal line here is the x-axis. Is the function found anywhere below the x-axis? Anyone tell me, is this function found anywhere below the x-axis? Because remember, less than 0 means below the x-axis. Do you see it below the x-axis? No. So what do we say then as our final answer? Because after critical value, graphical representation, this is the correct graphical representation. Final answer, what do we say? Final answer, guys. What do we say? What do we say? The function is not found anywhere below the x-axis. So what must we spit out with our mouth? The one says I don't know. And guys, this is where they make critical values a pain for most people. Most people don't know how to answer this question. They leave it hanging. Hey bana, 2 marks gone. Bye bye. Kapoof. Hey bana. Khomoto. 0. X is greater than 0 but less than 3. Haibo. Khomoto. Aye corner. Guys, here. You see, the one said no. There's no place where the function is below the x-axis. So therefore, we can only say, therefore, x has no solution. Because if you are saying there's no place where you can, yes, the one, you were the one. You see, the one is the one, truly. The one is the one, truly. Very good, the one. Sibonga. Indaliane 7. From positive infinity up until Italian. My guy, the condition must be read first. This guy. Less than 0. What does less than 0 mean? Below the what? The x-axis. Is the function found anywhere below this horizontal? Guys, this is the x-axis. This line that you draw here, it's the horizontal x-axis. Do you see the function anywhere below the x-axis? No. So therefore you say x has no solution. There's no x value that you can say this x value shows me the function being below the x-axis. So we don't say things that are not there. Please, 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 guys, we don't say things. Look at this one. Let's say the same question was there. X minus 3. Let's change the condition. What if that was greater than or equal to 0? I mean, sorry, not greater than or equal to 0. Let's say less than or equal to 0. What would we have said? Okay. The accent, yeah, I know, like, I mean, yeah, so I speak so nasty, like, unless you want me to be Rajesh and you want me to speak in an accent that is much more, I don't know, maybe appealing, yeah, then if you want that, I can always speak in that way. Or you want me to speak like the comrades, you can do anything, yeah. Or what you want. All right, let's look at this one, guys. If it says less than or equal to 0, less than or equal to 0, remember we explained less than means below the x-axis, but also we understand equal to 0 means on the x-axis. So when we read it, we say less than or equal. So it is to accommodate both conditions, less than or equal. So less than, okay, let's write the critical values first and then we can proceed. Critical values, x is equal to 3. Graphical representation. Three. Then answer. Less than below the x-axis. So let's start with below the x-axis. Is the function found anywhere below the x-axis? Yes or no? Just answer the question. Is this function, because one critical value means the function turns at the critical value, is the function found below the x-axis anyway? Let's first start with below, then we're going to move on to on. Is the function found below the x-axis anyway? This one? Yes or no? Just yes or no. Just a simple yes or no in the comment section. Is the function found below the x-axis anyway? Hebana. Sipe says no. Thank you, Sipe. Sipe, you are the Sipes. Langa lizele. Yo, ilanga lizele. Yo, ilanga lizele. Yo. Sibonga Italian. 7. No, it's not found. Thank you so much, guys. It's not found. So we know we have no answer for below the x-axis, but then we need to check equal to 0. Now, equal to 0 means on the x-axis. My question is the function found on the x-axis? Is the function found on the x-axis? Tell me this guy, is he found on the x-axis? The one says yes. Is this function found on the x-axis? Remember, the x-axis is this horizontal line. Is the function found on the x-axis? The one says yes. Cheese is eating cheese like a cheese girl or a cheese boy. Yes. Langalizele is full of sun. Manando is manando ring. Okay, very good. So the function is found on the x-axis. Where? At 3 exactly. Therefore, our answer, guys, x is equal to 3. Full stop. X is equal to 3. Why are we saying x is equal to 3? To accommodate on the x-axis. For which value of x is the function on the x-axis? It's where x is equal to 3. Hallelujah. Amen. Ke batla ho robala. Ke batla ho robala. S3. What S3? What is that now? S3. Rebecca8@gmail.com. Alright, so please, guys. Okay, I hope you understand. I hope we understand. Less than means below the x-axis. Equal to 0 means on the x-axis. So below the x-axis is a function found? No. On the x-axis is a function found? Yes. Where? X is equal to 3. Full stop. Amen. Okay. Let's check one more condition. One more, guys. One more condition. What if the question had said greater than 0? What if the question had said greater than 0 for one critical value? What if the function or the x inequality was saying greater than 0 alone? Okay, so critical value will still be x is equal to 3. Graphical representation is sketch. We know it turns. Please, guys. Now I almost feel like, it turns. Ne? It turns at 3. So greater than 0, what would we say? For which values of x is x greater than 0? You see, when we say greater than 0, we're still looking at above the x-axis. That's all we are looking at above the x-axis. We are not looking at on because there's no equal. We are just looking at above. So what would be the answer? Let's see what people have to say. Above. Okay. Which place is it not above? So what would be the answer? What would we write as our answer for this one? Which value of x is the function above the x-axis, where x is not equal to 3? Where x is not equal to 3. Okay, so bar is very important. You can say x is an element of real numbers, meaning all real values, they work, but x cannot be 3. I like that the one, but it's not full until we accept that it's true for all x values for this one, where the function is greater than 0. But there's only one exception. The one exception is where x is equal to 3, because that's on the x-axis. And for this, we are looking for only above the x-axis, not for on. But how would the answer change if we said greater than or equal to 0? If we had said greater than or equal to 0, how would have the answer changed? We would have not written this. We would have just said x is an element of real numbers. That's for every number under the sun. For every x value under the sun, the function is fine. If there was greater than or equal to 0, we would have said x is an element of real numbers. So please, guys, please take note of these when inequalities are concerned. Okay, are we ring? Hope we understanding, guys. Okay, I leave. Okay, please, guys, please. I'm not doing any of these. I am just saying to you guys, please take note. Hi, guys. There's no playing here. We are not playing. Yeah? We open the paper. We look. We like, yeah, full marks. 23 marks in the bag. You see? Okay, this was Free State 2024. Free State people. You can see. It's like same tradition. A nice factorization one. Product of factors equated to 0, straightforward. You look at 1.1.2 so beautifully. We expand standard form, quadratic formula. Bam! Inequality there. You know, hey, look at that inequality. Look at 1.1.4. They have the, what you might call, side equation. There's a double square root there, you see. 1.2 simultaneous. 1.3, your typical, what? Your typical 1.3 question. Might look complicated at first, but guys, you take a closer look, you're like, so Ghana, nice stuff. This is Chawebuli, you food for good. It's very gilala. Yeah, this is Chowtown, bros. It's Chowtown. Free State. I took care of their people. Let's look at this one. Look at the next one, guys. Look at this one. You see, this one designed to scare the masses. The masses they're panicky. Look at this one. Look at that. Question 1. Typical question 1, not typical as it typically should be. Gauteng province, they don't, these guys, they do, look at this, look at that. The way, I think a lot of kids would be like super intimidated. It's like, given, determine K if X is equal to 2. So this is like, a bit of mix of grade 8. You having to take X equal to 2, substitute into the equation, and then you are wanting to solve for K instead of X. So I'm thinking routinely kids usually anticipate that question 1 is a solve for X standard, that's what they expect. But guys, hey, we need to be mindful. Examiners now are changing things up there and there, we must be ready for anything. Just a word of advice to all of you, please guys, as you prepare for paper 1, please don't put paper 2 out of your head. Paper 1 and paper nowadays, if you are preparing for paper 1, you better make sure paper 2 is well understood in your head. You can't be preparing a paper for paper 1 and think in your head, paper 2 I'm going to, because there's integration of topics nowadays. The examiners, they are integrating the topics. It is not going to be foreign now for you to find in 1.1. Maybe they have a circle diagram there, Hey, Bana. Hey, guys. Hey, imagine. Just imagine. Imagine this. Imagine this. Let me show you some. Guys, let's open the mind here. Imagine question 1. Imagine having a circle, right? And let's say a nice bow tie, and then let's say there's x squared here plus 3x, and then let's say there's x plus 5 here. Let's just imagine. I'm just saying, let's say there was x squared plus 3x here, and then here they have x plus 5, and then they like what, and they say solve for x. Okay, I'm just guys, I'm not saying any, I'm just saying, you see, what if they had x squared plus 3x here, and then they have x plus 5 here? Then they have this diagram A, B, C, D. This one would be a typical solve for x. But what do you see here? X squared plus 3x, all right, at the circumference of the circle A, and then x plus 5 at the circumference. So A and B, there's x squared plus 3x, and then there's x plus 5. Or let me say, brother, not x plus 5, 4, 5. Or let's say x squared, then there's, let's say, 3x plus 5. Okay, so let's say that, yeah, I think that's better. So if we had x squared plus 3x, and then here we had negative 3x minus 5. Negative 3x minus 5. Let's do this then. Okay. Sorry guys. X squared plus 3x, negative 3x minus 5. Okay. Imagine if that was the question. Okay. Yeah. But that's the thing, hey. Can it be angles in the same segment? Definitely, right? Then you would say angle A is equal to angle B. What's the reason? Angles in the same segment. You equate x squared plus 3x with negative 3x minus 5. You solve for x, you get the answer. Does this make sense, guys? Okay. Okay, what I'm saying is that we need to think outside this box, because you saw last year what happened with the grade 12's end of year final exam. What happened with the grade 12's? All of a sudden, solve for x was not your typical solve for x, because it did not have your two equations already there. There was a, they had to actually read a statement and then write expressions and equations using what they were reading in English. You see, set up the equations and then solve. And I think most of them were caught with their pants down. And we saw the effect that had on the general pass rate in mathematics across the country in almost all the schools, and just the decline in the maths pass rate in the country as a whole. All right. People who were getting level 7 during the course of the year found themselves getting level 6. There was a decline almost all across the board. And even the percentage pass rate in mathematics in the country took a nosedive. Why? Because our learners, obviously, they practice with the past papers and they anticipate that questions are going to come like this. So we need to be thinkers outside the box. That's why I'm basically saying this, right? We need to be familiar. We need to familiarize ourselves with the conceptual understanding of the topics that we learn in maths, so that we can be able to apply them where needed. So Manando, definitely. Angle A is equal to angle B. Angles subtended by the same arc or angles in the same segment. Then you take it from there. Especially if they would say, yeah, solve for x, provide a reason. You say, imagine. Okay, and then you're like, but this is paper 1. Well, what I'm saying is that please prepare for paper 1, but make sure that your paper 2 is up the alley. Anyways, most of you write on a Friday, paper 1, and that's the case. Then you have like the weekend to prepare for paper 2. So what's important nowadays, you guys need to become strategic. How? You make sure that you prepare for paper 1, whilst in conjunction making sure that the concepts in paper 2 are intact and you know what you need to be knowing. So let's practice the maths. Just practice the maths, please. Practice the maths. Get familiar with the concepts. Ensure that you have all the knowledge. Because biblically, what do they say about those who perish? People perish because they lack what? Knowledge. Let's make sure we have the knowledge all across the board. Are we together? Mwah. Okay, so this one, I'm sure those Gauteng province kids that year were like, huh? Okay, some of them, because they were not expecting the paper to open up like this, but it did anyways. Okay, the second one says determine x if k is equal to 2. So you take k is equal to 2, substitute there, you solve for x. So here at the top, we're solving for k when x is 2, when we substitute x is equal to 2. Here we are solving for x if k is equal to 2. So let us know that. Let's know things like that. Okay. Also, please guys, know your numbers. Like your number system, you must know it. Okay. We must all know what a whole number is. Let's start there. 0, 1, 2, 3, 4, 5, 6, 7 to infinity. Numbers that start at 0 increase by 1 to infinity. Know what a natural number is. Numbers that start at 1 increase by 1 to infinity. Know what a integer is. All positive and negative whole numbers that increase and decrease by 1. So from 0 we go up by 1. From 0 we go back by 1. From negative infinity to positive infinity, we are increasing and decreasing by 1. That is integer values. Okay, please guys, let's know our different types of numbers and the symbols attached to those numbers. Because if we don't know that natural number is just your symbol n without a subscript 0, that whole number is an n with a subscript 0, that your integer symbol is a z, that you know what your rational number is. Know what a rational number is, guys. A rational number is a number that can be written as a fraction. Numerator is an integer, denominator is an integer. Okay, and the denominator cannot be 0. Understand the concept of undefined. That a fraction cannot have a denominator that is 0. Numbers divided by 0 mean undefined. Understand the difference between undefined and non-real. Non-real, negative number underneath a even root. That's non-real. Undefined, division by 0. These are things that you need to generally know. So for general nature, okay, rational has a symbol for Q. There's like a Q without an apostrophe. That's rational number. The Q that has an apostrophe is your irrational number, your symbols for the different numbers. What the difference between a rational and an irrational number? Rational numbers, as I said, they can be written as a fraction, where the numerator and the denominator are integers, but denominator cannot be 0. Also, there's mixed fractions they are also rational. Improper fractions, they are also rational. Basically, fractions are rational, okay, as long as there's an integer in the numerator and the denominator, okay. What else? Irrational. Oh yeah, the decimals. For rational numbers, decimals are terminating, meaning they stop, okay. It's like all the numbers that you round off to a particular decimal place are called terminating decimals. Then recurring decimals. Those are the decimals where you have a number and then there's a dot on top of a repeating number, or there can be dots on top of the repeating number, or there can be a line on top of the repeating numbers. But numbers that repeat, after the comma, we call those recurring decimals. Recurring decimals and terminating decimals are all rational. The opposite is irrational. Those are non-terminating and non-recurring decimals. Please, guys, make sure that you understand that the symbols for rational, a Q, symbol for irrational, a Q with an apostrophe. Must know that. Then real and non-real. Real numbers are all the numbers in the number system, like all of them, okay? All the numbers in the number system on a number line, represented on a number line, including the rational and irrational numbers, okay? Then lastly, what is non-real? Okay, non-real, I told you that negative numbers underneath a even square root, those are non-real. We call them imaginary as well. Imaginary numbers, non-real numbers. There's a difference between non-real and undefined. So if you know those, because sometimes when they say solve for x, they'll say solve for x where x is an element of natural numbers. They'll say solve for x where x is an element of integers. Now, if you don't know that, that means you will answer and not take that into consideration, that they are asking you to basically represent your answer as a particular number, okay? So please, let's make sure. What do you mean, Pilile? Pilile is saying, show me why, for what? Dingindlela. What Dingindlela? You need the way, eh? Dingindlela, Pilile. A16 with pen, tab, something. Hey, which is cheesing there in the comment section. You cheese guy. All right, so please, guys, I think we're good here. 2x squared, solve for x. You see now, from this, they move to solve for x, correct to 2 decimal places. Then it's a third equation. Then look, 1.2.3, an uncharacteristic inequality. Here you are looking at a exponential function. Here you are talking about a linear function. And they are asking you, where does the product of these two show you them two being less than 0? In other words, the product of the y values for the functions, where do we see those being less than 0? Okay, and you can only see these being less than 0, the product of these two, where this one is positive and maybe this one is negative. Okay, there's no ways that this guy will ever be having y values that are negative. Why is that the case? Because if you look at this exponential 3 to the power x, it's the type of exponential where the a value is greater than 0, which means it will always be found above the asymptote. Which asymptote will be 0? The x-axis. So the function is never going to be negative. It's always going to be positive for all values of x. That's 3 to the power x. There's no need for critical values here, because here you are looking at the product of two functions, my guy. Product of two functions. This one, yes, does have a critical value, x minus 5. It is x is equal to 5. X is equal to 5 is a critical value for x minus 5 as an expression and as a linear function. Okay, so for me, to be honest, I would love to write the answer when I see the graphical representation of the two. So for instance, I think this one deserves a bit of attention. Guys, there's no ways there's no place where 3 to the power x, okay? Yeah. I'll see you. I'll show you just now. So, guys, remember, exponential function is represented in this form. Okay? Whenever this a value, all right, meaning the number that comes before the carrier, in exponential functions, there's the carrier of the variable exponent x. Who carries? B is the one that carries. A stands next door supporting B. So for instance here, 3 is carrying. Okay? 3 is the one carrying x. So it is B. Then next to 3, there is, because this one is positive, it means there's a positive one. Okay? So the thing is with A, as long as A is greater than 0, as long as A is positive, your function of the exponential function is always going to be found above the asymptote. Okay? As long as a is positive, your function of the exponent is going to be found above the asymptote. Now, since this is 3 to the power x, guys, y is equal to 3 to the power x is typically a function where a is 1, meaning it's found above the asymptote. Then the asymptote, okay, there's no q value here, meaning it's 0. Okay, this function is going to be found above the y-axis. It is. Okay, and I mean, there's no x-intercept, but there's a y-intercept. Okay, 3 to the power 0 is 1. Okay, so graphically, if you're looking at this function, you are looking at something like this. Okay, are we together there? That's the exponential. Then I want to look at x minus 5 because that's a linear function. It's a straight line. Okay, since the coefficient of x is positive, that means it's an increasing straight line. It has an x-intercept. Since it's x minus 5, it will have an x-intercept. X minus 5 is equal to 0. That means x is equal to 5. Okay, so it will cut the x-axis at 5. All right, I'm just thinking if it's y is equal to x minus 5. That's the function. If you let x be equal to 0, y is negative 5. So it's negative 5 and 5. So that means this is the straight line. Graphically speaking, that's what we are seeing. Now, please guys, this is 3 to the power x. And this guy here at the bottom is y is equal to x minus 5. Okay, y is equal to x minus 5. I hope we can yeah, because what did they say here? 3 to the power x. Okay, 3 to the power x times x minus 5. This is no different from those typical questions you usually get for functions where they say f of x times g of x less than 0. Okay, this is the function of it's an exponential function, 3 to the power x. So we would say f of x times, this is a linear function, it's a straight line, it's an increasing straight line, it's g of x. So what do we typically look for here for the product of two functions less than 0? We are looking for where y of f of x should be either positive times what will give us something that is less than 0, meaning something that's negative. And then the y of g of x should be negative at the same time. If we can get a combination where the y of f of x is positive and the y of g of x is negative, what's a positive times a negative? Doesn't that give us a negative? So that's one of the conditions we are looking for. The y of f of x is positive, whilst the y of g of x, which is x minus 5, is negative. The two should give me something less than 0, because a positive times a negative for y gives me a negative. Are we together, guys? The product. Or the second condition, if we could find the y of f 3 to the power x being negative, whilst the y of g is what? Is positive, then that will also give me a negative outcome. So these are the two major conditions I want to check for in my sketched functions. Hey, guys, are we following this? Let me take this one step at a time. I'm saying 3 to the power x represents a function. What kind of function? Exponential. X minus 5 represents a function. What kind of function? Straight line. What is the relationship between 3 to the power x and x minus 5? It's definitely, obviously, going to be the product of the two functions. What does less than 0 mean? It means negative. What product of two functions? Okay, what product of two functions gives you something that is negative? It's when y of f of x, which is 3 to the power x, is positive, whilst at the same time the y of g of x is what? Is negative. The product of a positive and a negative for y should give me a negative outcome. So that means this situation satisfies this inequality. So I want the x values that show this condition. Or the y of f of x, which is 3 to the power x, should be negative, whilst at the same time the y of g of x, which is x minus 5, should be positive. A negative times a positive gives me a negative, which is the outcome I'm looking for. This outcome would also satisfy the equation. But guys, is this guy here, 3 to the power x, ever going to be negative? That's the question. So that means this one is out, because this guy, he's always positive. Okay? He is always positive. We are busy with 1.2.3 optimal goal. He is always positive. 3 to the power x. So that's why my drawing, you see my drawing here, y is equal to 3 to the power x is this function. What can you say about this function? The y values are always positive. Always, guys. So let me just show you. If I label the plus, these are the plus signs for y. That show how the function is everywhere for y. It's positive everywhere. Then let us go to the other function. Okay, what's happening here? Okay, the function here is what? Okay, the function here is negative. It's negative up until this x-intercept here. Then what happens after that? It starts being positive. But do you see that here, where x is 5, x is greater than 5, both the functions are positive. We don't want a positive times a positive, because a positive times a positive gives us a positive. We are interested where the two, you can see here, where x here, where x is less than negative, less than 5, where x is less than 5, that's where we get our answer. Where x is less than 5, the y of this 3 to the power x is positive, and it does so being positive to infinity, negative infinity, to negative infinity, from negative infinity to 5. Okay, then the straight line, when x is less than 5, the y values are negative. So what's a negative times a positive? Negative times positive, that gives me a negative outcome. So my answer here is when x is less than 5. Okay, this is from my graphical representation. 3 to the power x, always above the asymptote, meaning always above the x-axis, meaning it's always positive. The y values are always positive. My straight line x minus 5, here it is, guys. This is my straight line x minus 5. Passes through the x-intercept, 5. Okay, so if I compare the two functions, where do we see this condition? The y of 3 to the power x is positive, whilst the y of g to the power of gx, which is x minus 5, is negative. It's when x is less than negative 5. You can see as I move here, he's positive, he's negative, he's positive, he's negative, he's positive, he's negative, he's positive, he's negative. It happens all the way. Hence, I'm saying when x is less than 5, or we could say where x is an element negative infinity to 5, open brackets. That is another way of writing the answer for 1.2.3. So my recommendation is just through the sketch. Sketch won't go wrong. Okay, but also if you can perceive the fact that this guy is always positive. So when the only thing you want to check is, when is this guy ever going to be negative? Because the positive that is always going to be there, because this 3 to the power x is never going to have a y value that is negative. Never. But as for x minus 5, there is a portion of this function, x minus 5, where it becomes negative. Because you are expecting that a positive times what? A positive times what should give you something less than 0? A positive times a negative. Wangwa. Guys, I hope you are wangwaring me. Like, if you're not wangwaring me, I don't know. Like, who will you wangwa if you don't wangwa me? If you don't wangwa me, I don't know who you will wangwa, guys. Yo. Okay. All right. So, can I take this? I think I've over-explained it now. Optimal Guru is like 1.3. You guys are so hilarious. The minute I explain something and you are fine, now you think you can just tell me what next to do, right? The one is like, what? Black Teddy, can I explain 1.3? Yeah, that's a what? I like it. I like it a lot. All right. Okay. I like it. Black Teddy is like, I like it. Okay, let's bring this human voice. Black Teddy is like wanting to explain it. Let's give him. He's like, don't you judge. Are you a teacher or a learner? My guy, I am a teacher or a learner. My guy, I am a teacher or a learner. My guy, I am a teacher or a learner. What's happening there? Like, it's repeating itself. My guy, I am a teacher. Oh, my soul. What's happening with your network, Black Teddy? Teddy Black. The Black Man. The Black Man. The Black Man. Black Teddy, your network is fighting, my guy. It's fighting. Okay, so this one really should be quite straightforward for most of us, guys. Okay, it's a matter of unleashing. We need to unleash 3 to the... And I think many people, the only problem that they would encounter is just this 3 to the power x. Remember, guys, there's this guy, exponents. Please, a to the power m, nth root, the nth root of a to the power m, that is a to the power m over n. Let's not forget this guy. Let's not forget him. To remove the root, the nth root, okay, he belongs in the numerator of the fraction. He belongs to the denominator. That's how we remove the root, so that it is represented in rational form. Are we together, guys? So this here will be written as what? The square root of 3 to the power x. We know it's going to be written as 3 to the power x over 2. Wangwa. And then this one, 9. It will be 3 squared to the power y. Wangwa. Which is equal to 3 to the power 3. Wangwa. Okay. Yeah, because the intention is to apply our exponential laws by changing all the composite base numbers. What is a composite number? A composite number is a number that has more than 2 factors. That's a composite number. So for instance, 9 is a composite number. The factors of 9 are 1, 3, and 9. You see? So we write 9 as a prime base. What is a prime number? And the prime number is a number that has only two factors, 1 in itself. So we change 9 to 3 squared. And our calculator can help us there mostly, because we know any number like that, we can say 9 is equal to, we press shift, we press blood effect, and then the calculator just, 3 squared. That's how we can use our calculator for the purpose of changing these. So yeah, then we know most multiplication. Okay, so we have 3 x over 2 times 2 times y, that's 3 to the power 2y, which is equal to 3 to the power 3. Then the bases are the same on the left, so what do? Keep the base at the exponent. We know most, that's going to be 3 to the power x over 2 plus 2y, which is equal to 3 to the power 3. And when the bases are the same, on either side of the equal sign, we can drop the base, equate the exponent. So our linear equation, which was hidden, we can make y or x the subject. Yeah, we can do that, because when there's a 2, you just multiply throughout by the LCD, which is 2. So we get x plus 4y is equal to 6. Then we make x the subject. That becomes 6 minus 4y. Then we know that's equation 3. Yeah. Then okay, we know what to do from there, guys. So it's a matter of changing the exponential equation into a linear. Look, Yusuf. And all we did was just apply our exponential laws to do that. So please don't forget this guy. You see, this guy here is very critical. Vice versa, this to that, vice versa from that to this. 3 to the power x over 2 times 9 is 3 squared to the power y, equal to 27 is 3 cubed. Then what do? We apply law number 1 of exponents. The bases are the same. We are multiplying. What do? We keep the base 3. Okay, first and foremost, 3 to the power x over 2, 2 times y, 3 to the power 2y is equal to 3 to the power 3. Then most bases are the same. On one side, you keep the base 3, you add the exponent x over 2 plus 2y, which is equal to 3 to the power 3. Then after that, the numbers are the same on either side of the equal sign with the exponents. So we can drop the base, equate the exponents. X over 2 plus 2y is equal to 3, that's 3. Then from there, our denominator, our LCD is 2. So we multiply each term in the equation by 2 so that we can have an equation that has no fraction. Multiply by 2 here, we get x. Multiply by 2 here, get 4y. Multiply by 2 here, we get 6. Then you make x the subject. X isolated, take 4y to the other side, have 6 minus 4y. I think from there, guys, you should know what to do. In the place of x, you are going to now replace 6 minus 4y, where in the place of x, you substitute who? 6 minus 4y, where in the place of x, you substitute what? 6 minus 4y, where in the place of x, you substitute what? 6 minus 4y, where in the place of x, substitute for, no. Marshmallow. No, I think you're just a marshmallow. It's not that you're dumb. You're a marshmallow. You are mushy inside and soft like a mother's touch. Nah, I doubt you are dumb. I think it's so unhealthy to be having that kind of internal language with yourself. That's the best way to kind of like put yourself off. Yeah, don't say that. Don't say that for too long. By the way, guys, we as people, we tend to be the most negative with ourselves. It's insane. We are most negative. We are our worst critics. People outside don't even say half of the things that we say to ourselves. Like, some of us, we have, I think, what is it? Imposter syndrome. Yeah, imposter syndrome. So, Marshmallow, please, my girl, don't do that. Yeah, the one, thank you for also coming in and playing your role there. Okay, yeah. Anyway, most what you do, you take the 6 minus 4y, you substitute it there in the place of x, and then you solve. You can solve for y and get the yeah. So you come here, you see 6 minus 4y, you go and substitute 6 minus 4y plus 4y squared is equal to 6. From there, guys, kindo fire, kifire yo. Can see most 4y squared minus 4y, 6 minus 6 is 0. And you can take out the highest common factor 4y, you get y minus 1. So 4y is equal to 0, or y minus 1 is equal to 0. When we get the 1, divide both sides by 4. So y is equal to 0, or y is equal to 1. After getting your y values, don't forget you are not done, because now we need to take the y values and send them to that subject, which is x. Mostly this was waiting for the y values to come and be substituted. So now you can say x is equal to 6 minus 4 into 0, which is x is equal to 6. And then you take the other one, which is 1. You say x is equal to 6 minus 4 times 1, which is 6 minus 4, which is 2. So let's get x is equal to 2. So do you see the answers we get here? Yeah. When we solved, we got y. Y is equal to 0, y is equal to 1. And after doing so, we take the y values, we go and substitute them back into the equations. We get x is equal to 6, and x is equal to 6 and x is equal to 2. Okay, guys, I think simultaneous equations of that nature are very fun. Marks are very high. Pressure is very high. Beauty is very high. Love is very high. I am high. I am high. Goodbye, goodbye. It's time for us to go. Goodbye, goodbye. It's time for us to go. It's time for us to swap. Okay. Then here, state the values of p for which this equation will have. Okay. So this is another nature of roots. Remember, we had in the Eastern Cape paper the nature of roots question that we did together, né? But that one was saying for which values of k we had to actually utilize, finding the actual equation in standard form, which we then had to find the discriminant of and solve and use the condition. Okay, now in this Gauteng paper here, they are giving us the roots, the solutions of a quadratic equation. They are given. And what are they saying? State the values of p for which this equation will have what? 2 equal solutions. 1. And then what? The second one? No real solutions. State the values of p for which this equation will have 2 equal solutions. Okay, so here now we don't have an equation and the standard form of the original equation in terms of p. Rather, we have z discriminant. Okay, z discriminant. What do you mean I scrolled through so many questions? Passed so many questions? I didn't pass so many questions. I didn't. Okay, the questions I've come from there. When I am saying I must scroll up, I've come from there, right? The others I just perused through and I said, these questions, please guys, go and look at them. Okay, like you did a lot. Yeah. I some of the other questions I didn't do. I said, at least this, I asked people, which question would you like me to do? Okay, and then I was able to attend to the questions that people felt like I should do, right? And some of the others I just explained and spoke about. Man, I'll come back next time. You is smart. No, me is not smart. Me is just been doing this for a long time. Whenever you do something for a long time, You appear to be smart. I'm sorry to say so, guys. I'm not smart. Just that I've been doing this for a long time. If I promise you, if you were doing this for as long as I've been doing it, then you'd also have maybe you are smart, but I am not, to be honest. It's just a matter of doing this for a long time. So the experience of it now is affording me the chance to be able to share with y'all. All right? What? But thank you for the compliments. Much appreciated. Like I really appreciate you. Like I mean, like really, like yeah. Yeah, but can't you wait 18 seconds when starting a new question? We are snail pace. Who's this guy? Optimo Guru, 90 plus. Optimo Guru, you're a 90 plus Mets roller. So, what? Okay. So, guys, please take note of this. This is very important. You must know that this guy here, delta into 2x, 2p plus 5 inside the square root, delta. Because remember, in your quadratic formula, when you write down the equation, there's this part here. So now these people are saying the solutions of a quadratic equation are given by. So that means, guys, the b squared minus 4ac you see inside here is actually delta, which is basically going to be the expression inside that square root. So what's beautiful here, we don't have to go and find the equation, then find delta by substituting a, b, and c. That delta expression is underneath the square root. We just go and harvest it. Okay. And then they are saying state the values of p for which this equation will have two equal. Remember, when they say two equal solutions, that means delta is equal to 0. So let's go take and harvest what's underneath the square root. What is underneath the square root? 2p plus 5. We just equate that to 0. Then we solve. And that's it. P is equal to negative 5 over 2. What is P equal to? Negative 5 over 2. Two things. When they say two equal solutions, that infers delta is equal to 0. That's like them saying roots are equal. State the values of p for which the roots are equal. That's what the language you are used to. But then they're saying now two equal solutions. It's the same thing as saying the roots are equal, which is the same thing as saying delta is equal to 0. Where is delta? Underneath the square root. You take 2p plus 5, you equate him to 0, then you solve for p. So that is the p value. The value of p for which this equation have two equal solutions when p is negative 5 over 2. We together? Are we good? Are we good? Are you feeling me, my brothers and sisters? That really disturbed my cerebrum. Cerebrum. Yeah, well, it doesn't have to disturb your cerebrum anymore, hey? We are making sense of it now, okay? Are we good now? The solutions of a quadratic equation are given by. That's the solutions, okay? That's like the solutions you would get by when you are using the quadratic formula. So now you got the solutions in terms of p. There's two of them, negative 2 plus minus the square root of 2p plus 5 over 7. So now, what am I saying? Say the values of p for which this equation will have two equal solutions. What do? We take the discriminant, which is 2p plus 5. It's situated underneath the square root. Then we check the condition. What is the condition? They want the values of p for which the equation will have two equal solutions. What does that mean? Two equal solutions is the same thing as saying equal roots, which means delta is equal to 0. Substitute that, you solve for p, you get the answer. Then here, what does this mean? Anyone tell me what does this mean? When they say state the values of p for which this equation will have no real solution. No real solution means what for delta? What does that mean for delta? No real solution. Solution I equal. Yes, the one. It means delta Yes, Mondli. Mondli. Mr. Mdleche. You are Mdlechering, my guy. Okay, wondlekile Mondli. Wondlekile. Wondlekile uMdleche. uMdleche uyadlecha. Umdleche. Ah. So delta less than 0. Okay, that's no real solution. Then we Dutch just take 2p plus that 5. We say less than 0. Alright? And then we solve that thing. Solve that thing like we've never solved it before. This is a linear inequality, sorry. So linear inequalities, at least they are not... So there it is, guys. Oh, Mondli Mdleche discriminant. Is that your new surname? Okay, very nice. Mondli Mdleche discriminant. Yeah. As long as you're not discriminating, Mondli. Yeah? You just udla into echa. Okay, p is less than negative 5/2. That's basically it. Okay. Okay. So this question one was not too shabby. Huh? Yeah. From Gauteng to the Free State, to the state that is free, guys. You know, to the Eastern Cape. Yeah. Aye. Things were well. Things were interesting. Things were fun. Back in them days. To KZN. Yeah, well. Haha. Ngwaneso. To KZN. Zulu, yeah, KwaZulu. Ibheka yamina le. Nixi mapa nixi. Ibheka yamina le. Nixi mapa nixi. Ibheka yamina le. Yeah. What you Zulu? Yeah. Guys, unfortunately, I have to love and leave you. I have an early morning this morning, but thank you for joining in. I think I'll try now consistently do these lives like at night, like in the evening, well, like maybe after 11 or after 10, okay, just to sort of like sensitize us to some of the things that are critical and crucial. There's also your typical word problems which tend to feature and stuff. That was Limpopo paper. Unfortunately, I can't, guys. I have to sleep. I have to bounce. I have to bounce. Okay. If I don't, it will be very... So tomorrow, guys, tomorrow we'll do another one at 10. 10? Yeah, 10 to 12. Or 10 to 1. Or whatever, man. We'll see. 10 to 1. 10 to 12. Yeah, sleep is very important. I'll definitely do that. I'll upload on YouTube so you can see what I did here. And then, yeah, guys, I have a YouTube channel. Link is in my bio. These questions, what you want them. Okay, Northern Cape. This year's different province, Mpumalanga. The Mpumalanga people. Link is in my bio, guys, for the YouTube channel. Mpumalanga. Link is in my bio for the YouTube channel. I'll try and download the video tonight this morning before I sleep. I don't think it will be able to finish. Yeah, Northwest. Yeah, you see. Hey, Northwest. Hey, Northwest, where they were Northwesting there. You see, they are 1.3 Northwest. Yeah. Look at Northern Cape's 1.3. Everybody was just pouncing it on 1.3 in the provinces. Look at Pumalanga's 1.3. Manando, feeling it close to home. Yeah, people are feeling their provinces here. Yeah? You are feeling your provinces. You people, right? Look at Western Cape. Where Eastern Cape? Yeah, where Western Cape? Where Western Cape? They even pushed it to 29 marks. Question 1. Talk about Western Cape, westernizing everything. Yeah, what the freaking doodle, man? What the freaking doodle? Eastern Cape was the first one, Optimokor. It's the first one that the province of the champions. That's where we started. We started with people. The minute I opened this question, people wanted me to do 1.3, so I did 1.3. When I started off, I did 1.3, and then people wanted to get a reminder on inequality, so I did inequalities, and then I did a variation of other inequality questions just for the benefit of those people that want to get clarity on other types of questions, the inequalities. That then led me to this inequality question, all right, which I did, and you guys then asked me to do that one as well, the exponential simultaneous equation, and I did the nature of roots type question as well there. Optimum Guru, I don't. This question, I actually answered, for instance, you see this 1.3, the Eastern Cape one, I answered this over and over again. I did this over and over again because people like kept on asking me. So I did this over and over again. So I think what I'll do is I'll try and I'll cut the segment where I did this question and I'll post it on my TikTok page. Just be patient with me though. Maybe I'll post it in 2 parts. Okay, so that and then tomorrow we'll see if we can just do others as well, from other provinces. But you guys are giving me the fire to do it. It seems like you guys are interested. We'll get to number patterns eventually, functions, financial maths. See, you know what I mean? We'll see, because this is like the season to be jolly. Fa la 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 la. Merry Christmas, everyone. Cheers, guys. Thank you so much. It was good. Okay, thanks for those that did gift me or send a heart me and all of that stuff. I really appreciate you, and those who were liking and you commenting and participating and just being part and parcel of everything. Thank you so much. Please have a good one. Optimal Guru, you need the PDF. Send me. I have just send me a message, and see if I can't send you the link to my WhatsApp group, and then you guys can, because I sent my WhatsApp learners their WhatsApp group. I sent them the PDF with the document with the questions and with the memo, so that you can practice on your own. You don't need me to be live in order for you to, be doing the things. So if you're interested in that document, please, guys, send me. Just inbox me or something, and then I'll make a plan. Manando, we'll get to it. Okay, you want me to do functions immediately next? If that's your request, Manando, I'll definitely do it. You can see most functions are waiting. They are stuttering here. Different types of questions. See. I know, no problem. We'll get there. We can do it next time if you want. No, for sure. Okay, guys, good night. Let me love and leave you. Thank you so much for being here. I really appreciate you. And thanks for the follows, guys. Bye.